All right, so in this video, I'm going to actually discuss how to find standard deviation. So remember, we were talking about standard deviation is the average deviation from the mean. So first, let's discuss how to find mean. So mean is when you add them all up, divide by how many there are. Now, what that actually looks like mathematically when you write out that formula is, remember that when we're talking about a sample mean, we write x bar. So x bar equals actually the sum of all of your x's divided by n, your sample size. So let's just look at that. So when I have n, what is n actually? Let's figure out what that is. So how many numbers do we have? 1, 2, 3, 4, 5, 6, 7. So n equals 7. And if I add these all up, it's going to give me 119. So the sum of all of my x's is 119. And I'm going to divide that by 7. And that's going to give me 17. So my mean is 17. So now that I have the average of everything, now I want to know, on average, how far away from the mean do my data points actually stray or deviate? So I'm going to actually make a table that's going to go through the formula. So let's write down what the formula is first. So I'm going to write that off to the right over here, and I'm going to write it in red. So the formula for standard deviation is S equals the square root of the sum of each x value minus x bar squared divided by n minus 1. So remember that S is dealing with sample standard deviation because that's what we're going to be using most often. So now in blue, I'm going to make my different tables that's going to help us figure out what the standard deviation is. So the first thing I'm going to write down is a table with all of our x values. So our x values is just 14, 13, 20, 22, 18, 19, 13. 1, 2, 3, 4, 5, 6, 7. Just making sure I got them all. All right, so there are my x values. Now, the next thing that I have to do is, what I want to do first is, when you're looking at a formula, you always do what's in parentheses first, correct? So that is going to be x minus x bar. These are our actual deviations, right? My individual deviations. How far does each data point stray from the mean? And our mean is 17. So what I'm going to do next is I'm literally going to subtract for each one. I'm going to say, okay, 14, and you always put your x value first. 14 minus 17 gives me a negative 3. And then 13 minus 17 gives me a negative 4. We'll discuss about the negatives in just a second. And then 20 minus 17, and so I'm going to continue all the way down until I'm finished. Okay, so I've done all of my deviations. So the next part is what's right outside to the right of my parentheses, which is the squared. So now I'm going to take all of my deviations and I'm going to square them. And the reason why I am going to square all of my deviations is because of these negatives. Now, let's think back. Standard deviation is the average deviations away from the mean. So let's just pause and let's say we weren't going to square them. How would we find average? You add them all up, divide by how many there are. Okay, so let's just do that really quick. Let's see what would happen if I took all of my deviations, added them up, meaning like the negative plus another negative plus a positive, all of those, add them up, divide by how many there are. Let's see what we would get if we just left it there. So I'm going to put this at the bottom underneath it, just like here we're testing it out to see what would happen if we were just to add them all up and divide by how many there are. So I'm going to do that on my calculator. So when I added them all up, it gave me a sum of 0. And we all know that 0 divided by anything, which is going to be 7 because I have 7 deviations, that's not okay. Not okay. We can't do that, right? So the point is, the problem that we're having here is because of those negative numbers. This is why we have to square those negatives. So that's what we're going to do next. Square all of the numbers. I can't just do the negatives. If I do it to one of the negatives, I have to do it to all the numbers, right? Just like if you do it to one side of the equation, you have to do it to the other side of the equation. Same sort of thing there. So now I'm literally going to have -3 for the first one, -3 squared. And a negative times a negative equals a positive. So then I'll have 9. And then we'll have -4 squared, which gives us 16. And now I'm going to continue all the way down. Okay, so now we don't have any negative numbers because we squared them. That's how we get rid of those negatives. Now what do we need to do? Now we need to add them all up, or using that special sigma sign, which means to add. So we're going to take the total and we're going to add up all of these numbers here. All of the 9, the 16 plus 9 plus 25 plus 1, 4, and 16, and all of those added together gives us 80. So my total of them is 80. Now I need to divide by how many there are. Now, because we are dealing with a sample size, we are going to have to do our sample size minus 1. And the reason that we're going to do our sample size minus 1 can be complicated. We can do a problem if you really want to, but the short of it really is that if we don't subtract 1 and we just take it divided by n, we are always going to be underestimating the true standard deviation. And we don't want to underestimate the true standard deviation. So we are always going to be subtracting 1. So now, instead of dividing by we already know that n equals 7. So instead of dividing by 7, though, we're actually going to divide by n minus 1, so that would give us 6. And then 80 divided by 6 gives us 13.33, approximately. Now, that takes care of the adding them all up, dividing by how many there are. However, though, remember that from before, previously, we squared all of these numbers because we needed to get rid of the negatives. But now we have to undo the square. So how do you undo a square in a problem? To undo a square, I hope that you're all thinking that we take the square root, which would be correct, which is the last chunk of our formula. So now I'm going to take the square root of 13.33, and that should give us a standard deviation of 3.65. So now, what that means is if I were to draw a tiny itty bitty little graph over here, and we'll just pretend. So none of this is right because we don't even have enough data to really look at it. But if I say that my mean lies in the middle, which is 17, we can say that on average, each data point is going to stray from the right by 3.65, meaning I'm adding it, or to the left by 3.65, meaning I'm subtracting it. So if I take 17 minus 3.65, I get really close to between 14 and 13. And then if I take 17 and I add 3.65, I get really close to that 2022 data point that we have. So it makes sense that on average, that's where our data lies, because that's what most of our data looks like, because we have 14, 13, 20, 22, 18, 19, and 13. So I hope that helps. I hope that makes sense. So remember, this is the long way of finding standard deviation, and when I come to your class, I'm going to go over how to find it in your calculator much faster than doing it longhand. But you need to know how to use the formula on your exam, and so now you do. I will see you in class.